name is Minji, and I'm a PhD candidate at University of Minnesota. And I'm also working as a research scientist intern at Meta Reality Lab. So smart gloves are advanced functional garments with embedded technologies, such as motion trackings or biometric monitorings, or like tactile feedback. So the image in this slide is one example of smart gloves, which is Meta's haptic glove prototypes. It is to support the human-computer interactions in virtual and then augmented reality system. And wearable, including smart glove, fit everyone very differently. So that is, glove fit has been a unifying challenge that has held these devices back from the widespread. And if the glove has a poor fit on the users, then they will feel like a physical discomfort, like tightness or looseness, and they also mentally will not be really happy to wear it. There are high possibility of malfunction of the sensors and actuators, and quantitative evaluations of glove fit with the objective measures have not been implemented for the smart gloves. The purpose of this study was to develop a high-resolution and point-based quantitative fit assessment method for smart gloves. And we aim for point-based analysis at the millimeter or sub-millimeter level even, which is required to understand the link between the hand and then the performance of the smart gloves. 3D scanning-based fit assessments in few studies were conducted by overlaying the unclosed and then the closed body as mesh deviation analysis to capture the air gap between the bare body and then the closed body. That they only provided overall air gap distribution with the heat maps, and they were not able to produce point-to-point fit data. And we really need for the point-based quantitative fit assessment to do some data-driven fit improvements. What fit elements will be the matter for the smart gloves? So first is proximity, which measures air gap, and then the second one is alignment, measures the point offset. So first step of fit assessment pipeline was generating 3D hand models. So we scanned 3D printed hand in ungloved and then gloved situations. Very detailed landmarks were needed. So it was mostly based on the anatomical locations. So the first fit analysis is mesh deviation analysis for proximity measure, which visualize the dimensional difference between the ungloved and then the gloved hand. Is the cross-sectional analysis, also quantifies the air gap for proximity measures. And alignment measures were quantified with the coordinate analysis, which was conducted by the comparing gloves and underlying hand landmarks. So that the individual air gap and the misalignment measurements were recorded. And then our next question will be how to deal with these numbers. To translate fit assessment summary data into the actionable design steps to improve the fit of the gloves. There are so many improvements that we have based on this fit analysis, but in first gloves and then the second glove prototypes. Second prototype has less red zones on the finger webs, and then also palm area, and then also the finger tip area. So the second glove prototypes follows the contour of the hands better with the less air gap. Alignment analysis, focusing on the joint of the fingers. So for those landmarks, misalignments was measured. So for the first prototypes, misalignments ranged from 4.8 to 6 millimeters. And in the second prototypes, it was ranged from 0.9 millimeters to the 2.7 millimeters. We still need the physical prototypes, but we consider the physical prototyping as a very costly and then also time consuming. So virtual fitting can be another things can be incorporated into our developed prototypes pipelines, and then by using virtual fitting simulations, we were able to get some of the fit assessment results by using a virtual fitting data. These pipelines, it will be possible to understand the physical coupling between the glove and then the hand for the functional and then non-functional hands, functional gloves, and then we can even understand the fit changes in the dynamic postures. By doing that, we can improve the user comfort and then also on-body functionality of the smart gloves.